Hey guys, welcome back. This we are looking at transformations of functions and relations. Now, the thing that I want to highlight is, I guess in previous chapter of parabolas and other graphs, I've already gone through dilations, translation, and inversion effects of quadratics, exponential graphs, hyperbolas, and circles. So rather than going through all of that again in this video, my suggestion is to go back to that playlist and go through some of the content that I guess revises for your own revision based on those effects. That'll just help the double up of things and make this video a little bit more streamlined and efficient. So what I want to focus on is the transformations with cubic and quartic functions. And what I want to highlight, I guess there's a lot of similar patterns and effects compared to the other functions that we visited early on in the year. And so therefore, that's why I want to just make that connection rather than go through it all over again from scratch, that you can draw those connections. So let's get started with our cubic function. So here's a standard cubic function of y equals x cubed. Nothing really spectacular about it. It goes through the origin. And if we were to change the coefficient of x cubed to a negative value, that is going to invert it, make it upside down. Okay, it's going to reflect it around the x-axis. It's just like with parabolas. If you have a negative parabola, inverted parabola, it's a frown rather than a smiley face. And then the same thing with, say, linear graphs. We've seen that if we were to change the gradient of the leading term to a negative polarity, then it switches it the other direction. So the leading term being the term that has the highest power. In this case, it's x to the power 3, making a cubic function. The coefficient is negative, therefore it's inverted. Now, if we were to, in comparison to x cubed, add a constant, just like y equals mx plus c or y equals ax squared plus bx plus c, that constant, that plus c, that c value is then going to identify the y-intercept, but also a form of vertical translation as well in this base form of a cubic function. Similar thing, if we were to subtract 2, it would shift it down 2 units, making the y-intercept at -2. Now, what we've seen in turning point form of quadratic functions as well as circles, we've seen a h value in our previous graphs. So then what we would expect here with our cubic function is that when we subtract or add a value to our leading term in brackets, it's going to have a horizontal translation effect. So what we have here, again, the same kind of weird effect. A -2 is going to translate it horizontally 2 units to the right. And therefore, anything that has a positive h value, that's going to shift it to the left. In this case, x plus 3 all cubed is moving it 3 units to the left. And we could see that the center of this base cubic function is at -3. Okay. Now, we also have a, I guess what you say, like a k value. If we were to revert back to, again, quadratics, parabolas, and circles, we have our horizontal translation, we have a vertical translation. And so what we have here, moving to the left 3 units, but then it's moving down 5 units. What we would expect with x plus 3 all cubed plus 4, it's going to move the graph 3 units to the right and 4 units up. So let's have a look at that. Yes, that's right. So we've got 3 units to the left and then 4 units towards going upwards. Now, we've done the translation of vertical and horizontal translation. We looked at the inversion. Now we're looking at the dilation. Okay, so how wide or skinny the graph ends up being. So what we've understood is if the gradient or the coefficient of the leading term is greater than 1, it's going to be skinnier, okay? And that's what we see here. So if I toggle on and off, we could see the comparison to x cubed. It's a lot skinnier in terms of dilation. If the graph, if that leading term, the value of a, the coefficient of x cubed in this case, is less than 1, between 0 and 1, so it's just a fraction, it's going to be wider, so it's more dilated. All right. And so what we can do is we can piece all of this information together just in terms of our expectation and understanding of how it affects with all the other functions that we've dealt with. Here we have just another function, y equals negative 1/5 of x minus 6 all cubed plus 3. And the idea is that you'll be able to predict the features. Here we have an inverted cubic function, so it's upside down. The coefficient of the leading term is less than 1, so it's a fraction. It's going to be wide, or at least wider than x cubed. It's going to shift 6 units to the right, and it's going to also shift 3 units upwards. So if we can tick all those boxes and make those predictions, what we see is exactly what we just described. It is inverted, it's flipped around, it's a lot wider than y equals x cubed. It has shifted 6 units to the right, and it's moved 3 units up. So it's a really good way to kind of draw those parallels with the other graphs that we've dealt with in the past and making those predictions. So moving on to quartic functions. So we've got polynomials which has a leading term of degree 4. The same pattern follows, okay? So here we have a quartic function of y equals x to the power of 4. Looks very similar to a parabola to some degree. If you make the leading term negative, it's going to invert it. If you're going to add a constant, it's going to move the graph up or down the certain values, and then obviously this constant can double up as the y-intercept when x equals 0 in its basic form. If we add an h value, so it's going to shift horizontally to the right if it's negative, it's going to shift to the left if it's positive. Okay, and then the same thing if we're going to add a k value to this, it's going to move it down if it's negative, it's going to move it up if it's positive. Dilation is going to be the same thing. So the higher the number, the skinnier the graph. Okay, and if it's less than 1 and greater than 0, it's going to be wider, it's more dilated. And then lastly, if we were to predict everything else, again, we've done just the same values here. So I've got the same values as what we did with the cubic function. So inverted, it is more dilated, it's shifted to the right, and then it is also shifted upwards 3 units in this case. So all of those things, it's very useful to see the patterns within the graphs and the transformations that takes place. So that's all I want to cover today and in this video, just to get you a little bit more aware about the transformations and the effects of certain values within, I guess, these functions, particularly these polynomials. And if you have any questions, let me know. Otherwise, have a great day, and I'll see you in the next video.